We're going to take a look at inverse variation, and this is in contrast to direct variation. And in direct variation, we had the equation that y was equal to k times x, so we had some proportionality constant, but we multiplied it. And again, this is for direct. And here we see, again in contrast, the formula for inverse variation, where we have y is equal to k divided by x. And whenever I see the word varies, I will substitute for the word varies, just equals k. And then when I see the word inversely, I make it a division relationship. If I had seen the word directly, I would have made it a multiplying relationship. And we can also express this as y is inversely proportional. And again, when I see the word proportional, I will put that it's equal to k, some constant, and then again, the word inverse or inversely means that I should be dividing. So the variables that we use don't always have to be x and y. They can be some variable. So we have this first variable on the left-hand side. The first variable varies or is proportional. And then we have the word inversely, which again means that the k will be divided by the second variable. So let's take a look at this example. We see the volume of a gas is inversely proportional to air pressure. So when I take a look at volume, I'm going to use the variable V to indicate volume. And then I see is inversely proportional. So the word proportional tells me that I should be setting this equal to some constant value, but then the word inversely says I should be dividing here. And then air pressure I'm going to represent as P. So I'm establishing what I call this generic relationship, and this equation is almost complete. The only thing that's really missing is that this value k, the proportionality constant, should change into a number. And when I find the correct number that will sit in that place, I will have an equation that will express the relationship between V, the volume, and P, the pressure. So I first start off with this generic relationship that I use by translating the sentence. And now I'm going to put in specific values that are designed to help me find the value of k. So I'm told the volume is 80 cubic inches, so I'll plug that in for V, so I get my 80 over here, at 15 psi, and so that's the pressure, and then I have my k is still in the numerator, but the pressure again is 15 psi. And it doesn't ask us to find the value of k, but in order to answer this question, I'm going to need to go back and find that value. So we can think of this as being a proportion problem and say that 1 times k is equal to 80 times 15, and that comes out to be 1200. And this number here for k has no units. But what we will do with it is take that value that k is equal to 1200 and put it back into the original equation. So we're going to take this generic equation, which has an unknown value for k, and make it into a very specific equation that we can say that volume is equal to 1200 divided by P. And that's really all that we need, again, to establish this equation, which sets a relationship between V and P. So now we'll go back to answer the question, which is, what is the volume at 25 psi? So 25 psi is a pressure, and we'll plug that in for P. So we get then from the equation that V, the volume, is equal to 1200 divided by our 25. And we'll leave the units alone for now, but when we work out those numbers, we end up with 48. And finally, to get the units, I'm going to note that my original volume units were in cubic inches, so I can do the same here and say that this is going to be 48 cubic inches. And that is my solution.